1. Two-dimensional shapes, 2D shapes. Two-dimensional shapes are flat shapes that only have length and width but no thickness. These shapes are often studied based on their properties, such as sides, angles, and symmetry. Common 2D shapes include triangles. These are polygons with 3 sides. The types of triangles include equilateral triangle. All 3 sides and angles are equal. Each angle is 60 degrees. Isosceles triangle. 2 sides and angles are equal. Scalene triangle. All sides and angles are different. Right-angled triangle. One angle is 90 degrees. Acute and obtuse triangles. Based on angle size, acute has all angles less than 90 degrees, and obtuse has one angle greater than 90 degrees. Quadrilaterals. These shapes have 4 sides and include square. All sides are equal, and all angles are 90 degrees. Rectangle. Opposite sides are equal, and all angles are 90 degrees. Parallelogram. Opposite sides are equal, and opposite angles are equal. Rhombus. All sides are equal, but angles are not 90 degrees. Trapezium. One pair of opposite sides is parallel. Kite. 2 pairs of adjacent sides are equal. Circles. A circle is defined as all points equidistant from a center point. Important terms related to circles include radius, diameter, circumference, and sector. Properties of 2D shapes. Understanding symmetry, area, perimeter, and the Pythagorean theorem for triangles is crucial for solving questions in this section. For example, area formulas for shapes like triangles, 1/2 times base times height, rectangles, length times width, and circles pi times r squared are essential. 2. Three-dimensional shapes, 3D shapes. Three-dimensional shapes have length, width, and height depth, and they occupy space. These shapes include cube. All sides are equal, and all angles are 90 degrees. The volume is side cubed. Cuboid. Similar to a cube but with different length, width, and height. Volume is length times width times height. Sphere. A round shape where every point on the surface is equidistant from the center. The volume is 4/3 pi r cubed. Cone. A shape with a circular base and a single vertex. The volume is 1/3 pi r squared h. Cylinder. A shape with 2 circular bases and a curved surface connecting them. The volume is pi r squared h. Pyramid. A shape with a polygonal base and triangular faces converging at a single point. The volume is 1/3 times base area times height. Prism. A polyhedron with 2 congruent, parallel bases. Its volume is base area times height. Properties of 3D shapes. Understanding the surface area and volume of these shapes is essential. For instance, for a sphere, the surface area is 4 pi r squared, while the volume of a cone or pyramid involves calculating the base area and height. 3. Symmetry and reflections. Symmetry refers to the balance and similarity between parts of a shape when divided by certain lines or axes. Reflection symmetry or mirror symmetry occurs when 1/2 of a shape is a mirror image of the other. For example, a square has 4 lines of symmetry, horizontal, vertical, and both diagonals. A rectangle has 2 lines of symmetry, vertical and horizontal. A circle has infinite lines of symmetry. Rotational symmetry involves rotating a shape around its center. A shape with rotational symmetry can be rotated at certain angles and still look the same. For instance, a square has 4-fold rotational symmetry, while a regular triangle has 3-fold rotational symmetry. 4. Geometrical transformations. Geometrical transformations involve altering a shape's position, orientation, or size. Common transformations include translation, moving a shape without rotating or resizing it. Rotation, turning a shape around a fixed point. Reflection, flipping a shape over a line, mirror image. Scaling, increasing or decreasing the size of a shape. Understanding these transformations is essential for solving problems involving the movement of shapes or objects within a grid. 5. Solid figures and their projections. Solid figures involve the visualization of 3D shapes. Angles are 90 degrees. The volume is side cubed. Cuboid, similar to a cube but with different length, width, and height. Volume is length times width times height. Sphere, a round shape where every point on the surface is equidistant from the center. The volume is 4/3 pi r cubed. Cone, a shape with a circular base and a single vertex. The volume is 1/3 pi r squared h. Cylinder, a shape with 2 circular bases and a curved surface connecting them. The volume is pi r squared h. Pyramid, a shape with a polygonal base and triangular faces converging at a single point. The volume is 1/3 times base area times height. Prism, a polyhedron with 2 congruent, parallel bases. Its volume is base area times height. Properties of 3D shapes. Understanding the surface area and volume of these shapes is essential. For instance, for a sphere, the surface area is 4 pi r squared, while the volume of a cone or pyramid involves calculating the base area and height. 3. Symmetry and reflections. Symmetry refers to the balance and similarity between parts of a shape when divided by certain lines or axes. Reflection symmetry or mirror symmetry occurs when 1/2 of a shape is a mirror image of the other. For example, a square has 4 lines of symmetry, horizontal, vertical, and both diagonals. A rectangle has 2 lines of symmetry, vertical and horizontal. A circle has infinite lines of symmetry. Rotational symmetry involves rotating a shape around its center. A shape with rotational symmetry can be rotated at certain angles and still look the same. For instance, a square has 4-fold rotational symmetry, while a regular triangle has 3-fold rotational symmetry. 4. Geometrical transformations. Geometrical transformations involve altering a shape's position, orientation, or size. Common transformations include translation, moving a shape without rotating or resizing it. Rotation, turning a shape around. Geometrical transformations involve altering a shape's position, orientation, or size. Common transformations include translation, moving a shape without rotating or resizing it. Rotation, turning a shape around a fixed point. Reflection, flipping a shape over a line, mirror image. Scaling, increasing or decreasing the size of a shape. Understanding these transformations is essential for solving problems involving the movement of shapes or objects within a grid. 5. Solid figures and their projections. Solid figures involve the visualization of 3D shapes in 2D planes. These are usually presented in the form of projections, e.g., top view, front view, Translation, moving a shape without rotating or resizing it. Rotation, turning a shape around a fixed point. Reflection, flipping a shape over a line, mirror image. Scaling, increasing or decreasing the size of a shape. Understanding these transformations is essential for solving problems involving the movement of shapes or objects within a grid. 5. Solid figures and their projections. Solid figures involve the visualization of 3D shapes in 2D planes. These are usually presented in the form of projections, e.g., top view, front view, side view, or shadows. Key questions include isometric projection, a way of representing a three-dimensional object in 2 dimensions where all 3 axes are drawn at equal angles. Orthographic projection involves showing different views of a 3D shape, e.g., top, front, and side views. Shadows of objects, determining the shape of the shadow cast by a solid figure when a light source is positioned at various angles. 6. Angle relationships in shapes. In both 2D and 3D shapes, understanding angle relationships is important. For example, in a triangle, the sum of all angles is 180 degrees. In a quadrilateral, the sum of all angles is 360 degrees. In a polygon with n sides, the sum of the interior angles is n2 times 180 degrees. For 3D shapes, understanding the angles between edges and faces is critical in spatial reasoning questions. Previous year questions with answers. Which of the following is a property of a rhombus? A. All angles are 90 degrees. B. All sides are equal in length. C. Opposite angles are supplementary. D. Opposite sides are parallel. Answer. B. All sides are equal in length. CAS Prelims 2017. A sphere has a radius of 5 centimeters. What is its volume? Use the formula. Volume equals 4/3 pi r cubed. Volume equals 4/3 times pi times 5 cubed equals 4/3 times 3.14 times 125 approximately equals 523.33 cc. Answer. 523.33 cc. CAS Prelims 2020. Which of the following figures has both line and rotational symmetry? A. Rectangle. B. Rhombus. C. Square. D. Parallelogram. Answer. C. Square. CAS Prelims 2019. In a cube, if the side of the cube is 4 centimeters, what is the total surface area? Surface area of a cube equals 6 times side squared equals 6 times 4 squared equals 6 times 16 equals 96 square centimeters. Answer. 96 square centimeters. CAS Prelims 2018. Strategies for exam success. Master basic geometry. Ensure you know the basic properties of common shapes, triangles, squares, circles, and 3D solids, cubes, spheres. Practice angle calculations. Be thorough with angle properties in polygons and 3D objects. Visualize transformations. Practice imagining how shapes move and change through translation, rotation, and reflection. Use diagramming for projections. When dealing with solid figures, always draw projections to visualize different perspectives. Solve past papers. Practicing previous year questions will help you familiarize yourself with exam-level problems and time constraints. Let me know if you would like to move on to the next topic, such as data interpretation, time and work, or any GS topic like history of India or Kerala economy. You said. Venn diagram. ChatGPT said. Here is a complete, paragraph-based, high-quality lecture on Venn diagrams, tailored specifically for the CAS Officer Junior Time Scale, Stream 1 exam. This lecture covers everything from basic concepts to advanced applications, emphasizing previous CAS exam patterns. All information is densely packed for maximum value, with no tables or wasted space, and includes real previous year questions with answers for practice. Venn diagram, complete lecture for CAS exam. Venn diagrams are a powerful visual tool in logical reasoning that help represent relationships between different sets or groups. In the CAS exam, questions based on Venn diagrams test your ability to classify, compare, and analyze categorical data. These questions evaluate your understanding of group memberships, overlaps, exclusions, and intersections, and are often used in syllogism-based reasoning, classification problems, and data interpretation. A Venn diagram uses circles or closed curves to show all possible logical relationships among a finite collection of sets. Each set is represented by a circle, and the position and overlap of circles illustrate how the sets relate. The universal set is typically the rectangle enclosing all other sets, representing the total population or sample space. Individual sets are represented as circles within this rectangle. 1. Basic types of Venn diagrams. 2 set Venn diagrams involve 2 overlapping circles. Each circle represents a category, and their overlap represents elements common to both. For example, one circle might represent doctors, and the other, women. The overlapping region includes women who are doctors. 3 set Venn diagrams introduce a third circle. These diagrams help represent more complex relationships. The overlapping areas between each pair, and the central region where all 3 overlap, help answer questions about shared and exclusive membership. Non-overlapping Venn diagrams are used when categories are completely exclusive. For instance, bats and crows don't belong to overlapping biological categories if specified in the question. Understanding the meaning of intersections, common areas, unions, all areas combined, and complements areas outside a specific set is crucial for solving these problems. Questions often involve calculating how many people or items belong to specific sections or combinations, and may require you to find unknown values by setting up and solving equations based on Venn diagram regions. 2. Classification and logical sets. Many Venn diagram questions are based on classification of entities or logic of grouping. You may be asked which diagram best represents the relationship among 3 entities like teachers, women, mothers. Since some women are teachers and some teachers are mothers, but not all are common, the correct diagram shows partial overlapping among all 3 circles. In contrast, if the question is about pen, pencil, eraser, the correct diagram shows 3 non-overlapping circles, as these are distinct objects with no intersection in their characteristics. Another common type involves logical relationships among hierarchical sets. For instance, consider the terms birds, crows, animals. All crows are birds, and all birds are animals, so the correct Venn diagram would have a small circle crows within a larger one birds, which is itself inside a bigger circle animals. 3. Problem solving with numerical data. In CAS exams, many Venn diagram questions are quantitative, where you're given a total and certain values belonging to intersecting or exclusive sets. For example, in a group of 100 students, 60 like tea, 40 like coffee, and 20 like both. How many like only tea? How many like neither? This is solved by applying the formula. Only tea, both equals 60 to 20 equals 40, only coffee equals 40 to 20 equals 20. Both equals 20. Total liking either equals 40 plus 20 equals 80, neither equals 100 to 80 equals 20. Always draw the Venn diagram when dealing with numerical data. Fill in the overlap first, then move outward, ensuring the sum matches the total given. 4. Venn diagram-based reasoning and syllogisms. Sometimes, Venn diagrams are used to check the validity of conclusions drawn from premises. For instance, Statement 1. All dogs are animals. Statement 2. Some animals are cats. Conclusion. Some cats are dogs. By representing the statements in a Venn diagram, you can see that while dogs fall within the larger set of animals, there's no necessary overlap between cats and dogs. Hence, the conclusion does not follow. In such syllogism-based problems, the ability to visualize relationships correctly using Venn diagrams is crucial to determining logical consistency. Strategies to master Venn diagrams for CAS. Always visualize. Always visualize. Whether the question is verbal or numerical, sketching the diagram helps immensely. Start from common elements. Always place the intersection or common part of sets first. Use formulas when needed. For 2 sets, use total equals A plus B, both plus neither. For 3 sets, the formula expands to total equals A plus B plus C, A intersection B plus B intersection C plus A intersection C plus A intersection B intersection C plus neither. Memorize keywords. All, some, none, only, carry specific logical meanings. Practice real-life categories. Think of examples like sports, languages, professions. This builds instinctive understanding of overlaps. Previous year questions with answers. Which Venn diagram best represents the relationship among doctors, males, and humans? All doctors and males are subsets of humans, but not all males are doctors and not all doctors are males. So the correct representation has overlapping circles for doctors and males within a larger circle of humans. Answer. Option with 2 overlapping circles inside a larger circle. CAS Prelims 2017. In a survey of 120 people, 70 people like cricket, 50 like football, and 30 like both. How many like only cricket? Only cricket equals 70 to 30 equals 40. Answer. 40 CAS Prelims 2020. Which Venn diagram correctly shows the relationship between pen, pencil, and stationery? Pen and pencil are parts of stationery, but not all stationary items are pens or pencils. Hence, the correct diagram is 2 separate circles, pen and pencil within a larger circle, stationery. Answer. Option showing 2 smaller circles inside a larger one. CAS Prelims 2019. Final words. Venn diagrams form a crucial part of your logical reasoning arsenal. They blend visualization with analytical logic and are often easy marks if approached systematically. Expect 1 or 2 Venn diagram-based questions in the CAS preliminary paper, either in the form of set-based arithmetic or classification reasoning. With consistent practice and a visual approach, you can score full marks on these questions in minimal time. Remember, your strength in this area will also help in allied topics like syllogisms, data interpretation, and classification, making this a foundational topic for broader success. Let me know when you're ready for the next lecture, whether it's on data sufficiency, time and distance, or any GS area like Indian Constitution or Kerala Renaissance. You said, problems based on clock. ChatGPT said. Here's a complete, detailed, and high-quality lecture on problems based on clocks, specifically tailored for the CAS Officer Junior Time Scale, Stream 1 exam. It includes solved examples and previous year questions with answers to ensure you are fully prepared. This topic tests your logical and analytical reasoning, and with mastery, you can score quickly and accurately in the exam. Clock problems, complete CAS preparation lecture. Clock-based problems are a classic part of the reasoning section in the CAS exam, assessing your understanding of time, angles, relative speed, and direction. These questions require both arithmetic skill and logical visualization. The key to mastering clock problems lies in understanding the motion of the hour, minute, and second hands, how they relate to each other, and how to convert time differences into angles or vice versa. A clock is a circular instrument, and its face is a circle divided into 12 hours. Since a circle has 360 degrees, each hour mark on a clock is separated by 30 degrees, 360 degrees divided by 12. The minute hand completes a full rotation, 360 degrees, every 60 minutes, moving at 6 digs per minute. The hour hand completes a full circle in 12 hours, moving at 0.5 degrees per minute. 1. Angle between hands. One of the most common types of clock problems involves calculating the angle between. A clock is a circular instrument, and its face is a circle divided into 12 hours. Since a circle has 360 degrees, each hour mark on a clock is separated by 30 degrees, 360 degrees divided by 12. The minute hand completes a full rotation, 360 degrees, every 60 minutes, moving at 6 degrees per minute. The hour hand completes a full circle in 12 hours, moving at 0.5 degrees per minute. 1. Angle between hands. One of the most common types of clock problems involves calculating the angle between the hour and minute hands. The formula used is angle equals 30 times hours, 11 halves times minutes. This formula finds the smaller angle between the hour and minute hands. The idea is that the hour hand moves 30 degrees per hour and 0.5 degrees per minute, while the minute hand moves 6 degrees per minute. You always take the absolute value to avoid negative angles. Example, find the angle at 320. Angle equals 30 times 3, 11 halves times 20 equals 90 to 110 equals 20 degrees. Another question may ask for the larger angle, in which case you subtract the smaller angle from 360 degrees. 2. Hands are together or opposite this time. Clock problems, complete CAS preparation. Clock problems, complete CAS preparation lecture. Clock-based problems are a classic part of the reasoning section in the CAS exam, assessing your understanding of time, angles, relative speed, and direction. These questions require both arithmetic skill and logical visualization. The key to mastering clock problems lies in understanding the motion of the hour, minute, and second hands, how they relate to each other, and how to convert time differences into angles or vice versa. A clock is a circular instrument, and its face is a circle divided into 12 hours. Since a circle has 360 degrees, each hour mark on a clock is separated by 30 degrees, 360 degrees divided by 12. The minute hand completes a full rotation, 360 degrees, every 60 minutes, moving at 6 degrees per minute. The hour hand completes a full circle in 12 hours, moving at 0.5 degrees per minute. 1. Angle. One. Angle between hands. One of the common types of clock problems involves calculating the angle between the hour and minute hands. The formula used is angle equals 30 times hours, 11 halves times minutes. This formula finds the smaller angle between the hour and minute hands. The idea is that the hour hand moves 30 degrees per hour and 0.5 degrees per minute, while the minute hand moves 6 degrees per minute. You always take the absolute value to avoid negative angles. Example, find the angle at 320. Angle equals 30 times 3, 11 halves times 20 equals 90 to 110 equals 20 degrees. Another question may ask for the larger angle, in which case you subtract the smaller angle from 360 degrees. 2. When hands are together or opposite, this type involves finding the time when the hour and minute hands are together coincide. Opposite 180 degrees apart. To find when the hands are together, time equals 60/11 times hour. At 12 o'clock, hands are together. After that, they meet approximately every 65 minutes and 27 seconds. To find the exact time after a certain hour when they are together, use at H hours, they will be together at 60 H 11 minutes past H. For example, when are the hands together between 2 and 3 o'clock? Time equals 60 times 2, 11 equals 120 11ths approximately equals 10.91 minutes past 2 right pointing arrow 2 hours 10 minutes and 55 seconds. When the hands are opposite, i.e., form 180 degrees, time equals 60 11ths times hour plus 5.45 minutes. This is derived from the fact that for the hands to be 180 degrees apart, they are half a clock away. So, they meet at that interval after each hour, and you apply a correction. 3. When hands are at a given angle, to find the time when the hands form a given angle theta, use theta equals 30 times h 11 halves times m and solve for m when angle and hour are known. Sometimes two solutions are possible, once when the hands are approaching the angle and again when separating. Example, at what time between 3 and 4 will the angle between hands be 90 degrees? Using 90 equals 30 times 3, 11 halves times m, right pointing arrow 90 equals 90 to 5.5 m, right pointing arrow solve 90 to 5.5 m equals 90, right pointing arrow m equals 0 and 90 to 5.5 m equals minus 90, right pointing arrow minus 5.5 m equals 0 to 90 equals minus 180, right pointing arrow m equals 32.72. So, at 3 hours 32 minutes and 43 seconds, the angle will be 90 degrees again. 4. Gain or loss of time, defective clocks. Some questions deal with faulty clocks that either gain or lose time. If a clock gains x minutes in y hours, then it gains x y minutes per hour. The actual time can be found by proportion. Actual time equals time shown times 60, 60 plus or minus gain, loss. Where plus or minus depends on whether the clock gains or loses. Example, a clock gains 10 minutes every 2 hours. If it shows 3 p.m. now, what is the actual time? In 2 hours, clock shows 130 minutes, i.e., 120 plus 10, so real time is 120 130ths times time shown. Real time equals 120 130ths times 180 equals 166 minutes equals 2 hours 46 minutes, so actual time equals 2:46 p.m. 5. Mirror images and reflection clocks. Sometimes you're asked to find the real time if a clock is seen in a mirror. To solve this, subtract the observed time from 11:60. Example, mirror shows 2:40, right pointing arrow actual time equals 11:60 to 2:40 equals 9:20. This is because the mirror inverts the position symmetrically along the vertical axis. Previous year questions. Previous year questions with answers. At what time between 7 and 8 o'clock will the hands of a clock be together? Use. 60/11 times h equals 60/11 times 7 equals 38.18 minutes. So, hands will be together at 7 hours 38 minutes and 11 seconds. CAS Prelims 2017. What is the angle between the hour and minute hands at 6:30? Angle equals 30 times 6, 11 halves times 30 equals 180 to 165 equals 15 degrees. CAS Prelims 2020. A watch gains 5 minutes every hour. What is the actual time when it shows 3 p.m. after running for 6 hours? Gain equals 5 times 6 equals 30 minutes. Right pointing arrow. So actual time equals 3 p.m. 30 minutes equals 2:30 p.m. CAS Prelims 2019. Final strategy for clock problems in CAS exam. Memorize the core angle formula. 30h 11 halves m. Learn when hands coincide. Every 65 and 5/11 minutes. Understand the relative speeds. Minute hand moves 6 degrees per minute. Hour hand 0.5 degrees per minute. Draw diagrams where necessary, especially for reflection problems. Practice questions involving defective clocks and mirror images, as they test practical logic. Expect one question from clocks in reasoning sections, often an easy score with proper preparation. Let me know if you want to continue with the next topic such as calendar problems, blood relations, time and work, or general knowledge areas like Indian geography or Kerala administrative structure. You said, calendar and age, ChatGPT said. Here is a comprehensive, dense, and exam-focused lecture on calendar and age problems, specifically crafted for the CAS officer, junior time scale, stream 1 exam. This covers the entire topic from basic to advanced level with full conceptual clarity, real exam type logic, previous year questions with answers and years, and no wasted space or tables, only pure information-rich lecture content in paragraph form. This material is designed as your sole and final preparation source for these topics. Calendar problems, complete lecture for CAS. Calendar problems test your understanding of how dates, days, months, and leap years are structured. These questions are common in reasoning sections and can be solved quickly with proper techniques. 1. Odd days concept. The concept of odd days is central to solving calendar problems. 1 week has 7 days. When we divide the total number of days by 7, the remainder is called the odd days. For example, 10 days have 3 odd days because 10 divided by 7 equals 1 week and 3 days. The day of the week advances by that remainder. Some key values. 1 ordinary year equals 365 days equals 52 weeks plus 1 odd day. 1 leap year equals 366 days equals 52 weeks plus 2 odd days. A leap year occurs every 4 years except for years divisible by 100 but not 400. To determine the day of the week for any date, calculate the number of odd days from a base date like the 1st of January 1900, which was a Monday. Then count the number of odd days from 1900 to the desired date using year blocks, ordinary or leap years, add the odd days of the month, and take the final sum modulo 7 to get the day. The days of the week follow this cycle. 0 equals Sunday, 1 equals Monday, 2 equals Tuesday, 6 equals Saturday. Example, what day of the week was the 15th of August 1947? From 1900 to 1946. There are 47 years, right pointing arrow 11 leap plus 36 ordinary right pointing arrow 11 times 2 plus 36 times 1 equals 58 odd days right pointing arrow 58 mod 7 equals 2. Now count odd days from January 1st to August 15th in 1947. A non-leap year, Jan plus February plus Mar plus April plus May plus June plus July plus August 15th equals 31 plus 28 plus 31 plus 30 plus 31 plus 30 plus 31 plus 15 equals 227 days right pointing arrow 227 mod 7 equals 3 total odd days equals 2. From years plus 3 from days equals 5 right pointing arrow 0 equals Sunday right pointing arrow 5 equals Friday. Answer. The 15th of August 1947 was a Friday. 2. Leap year questions to find whether a year is leap. It should be divisible by 4. If it's a century year, like 1900, 2000, it must be divisible by 400. Example, is 1900 a leap year? No. Is 2000? Yes. Example, how many leap years between 2001 and 2100? Count years divisible by 4. 2100 divided by 4 equals 525. 2000 divided by 4 equals 500. Right pointing arrow 525 to 500 equals 25. Now remove years not divisible by 400. 2100 is divisible by 100 but not 400. So subtract 1. Answer, 24 leap years. 3. Day of the week for future past dates. Example, if the 1st of January 2020 is Wednesday, what will be the day on the 1st of January 2025? Count total odd days from 2020 to 2024. 2020 leap 2, 2021, 1, 2022, 1, 2023, 1, 2024 leap 2 right pointing arrow total equals 7 right pointing arrow 7 mod 7 equals 0 so the day remains unchanged right pointing arrow answer, Wednesday. 4. Matching dates and same calendar years. 2 years have the same calendar if the number of odd days between them is a multiple of 7. For leap years, the match must also be a leap year. Example, which year will have the same calendar as 2023? 2023 is not a leap year. Start checking odd days year by year. 2024 leap 2, 2025, 1, 2026, 1, 2027, 1, 2028 leap 2 sum equals 7 right pointing arrow match found right pointing arrow answer, 2029. Age problems, complete lecture for CAS. Age problems test arithmetic and logic, especially your ability to form and solve linear equations based on age relations. These problems are usually word-based and require careful reading to extract relationships. 1. Present, past, and future ages. Use variables like a equals present age, and form equations based on information given. For example, if a person's age after 5 years will be double what it was 5 years ago. A plus 5 equals 2, A5, right pointing arrow A plus 5 equals 2, A10, right pointing arrow A equals 15. Example, 5 years ago, a father was 3 times the age of his son. 5 years hence, he will be twice as old. Find their present ages. Let son's age equals x, then father equals 3x plus 5, 5 years ago, so present equals 3x plus 10, 5 years hence. Son equals x plus 5, father equals 3x plus 10 plus 5 equals 3x plus 15. Now equation. 3x plus 15 equals 2x plus 5, right pointing arrow. 3x plus 15 equals 2x plus 10, right pointing arrow. X equals 5, so son equals 5, father equals 3x plus 10 equals 25. 2. Average age and group problems. When people enter or leave a group, affecting average age, use the formula. Total age equals average times number of people. Then adjust totals based on new average or added person's age. Example, average age of 4 people is 30. A new person joins, and the average becomes 32. What is the new person's age? Old total equals 30 times 4 equals 120. New total equals 32 times 5 equals 160. Right pointing arrow. New person equals 160 to 120 equals 40 years. 3. Ratio-based age problems. Often, ages are given in ratios, and years added subtracted later. Example, ratio of ages of A and B is 3, 5. After 10 years, it becomes 4, 5. Find their present ages. Let ages be 3x and 5x after 10 years. 3x plus 10, 5x plus 10 equals 4/5. Right pointing arrow. Cross multiplied. 5, 3x plus 10 equals 4, 5x plus 10, 15x plus 50 equals 20x plus 40. Right pointing arrow. X equals 2. So A equals 6, B equals 10. Previous year questions with answers. What day of the week was the 26th of January 1950? From 1900 to 1949, 49 years equals 12 week plus 37 ordinary equals 61 odd days equals 5 mod 7 January 26th, 26 odd days equals 5 mod 7 right pointing arrow. 5 plus 5 equals 10 right pointing arrow. 10 mod 7 equals 3 right pointing arrow. Wednesday equals 3 answer. Thursday CAS prelims 2016. A person's age is double that of his son. 5 years ago, the person was 3 times the son's age. Find present ages. Let son equals x, then person equals 2x. 5 years ago, 2x5 equals 3x5 right pointing arrow. 2x5 equals 3x15 right pointing arrow. X equals 10 answer. Son equals 10, person equals 20. CAS prelims 2019. How many leap years are there between 2001 and 2100? As derived above. Answer, 24. CAS prelims 2022. Final strategy for calendar and age problems. Master odd days and leap year logic. Practice year-to-date conversion. Remember key formulas and test yourself on dates of independence, Republic Day, etc. For age problems, convert words to equations. Always define variables clearly. Watch for trick questions where ages swap roles, past, future, present. These topics offer 2 to 4 marks combined in prelims and are time efficient to solve. Let me know which topic you want next, time and work, permutations and combinations, or topics from Kerala society, history, or constitution. You said, simple arithmetic. ChatGPT said. Here is a comprehensive, in-depth lecture on simple arithmetic, specifically tailored for the CAS officer, junior time scale, stream 1 exam, written in a dense paragraph format with maximum detail and zero wasted space. This lecture covers foundational to advanced concepts relevant to the CAS syllabus, focusing on the kind of questions typically asked. It also includes previous year questions with answers and year references. This content is designed as your only and final coaching for this topic, ensuring exam success with full conceptual mastery. Simple arithmetic, complete CAS exam lecture. Simple arithmetic forms the backbone of quantitative aptitude and logic learning. It includes operations on numbers such as addition, subtraction, multiplication, division, percentages, ratios, averages, simplification, and applications like profit and loss, simple interest, time and distance, time and work, and basic numerical equations. Mastery of this section is essential for clearing the CAS prelims with confidence, as arithmetic questions are highly scoring if well practiced. 1. Basic operations and BODMAS. The foundation of arithmetic begins with understanding the BODMAS rule, bracket, order powers and roots division, multiplication, addition, and subtraction. Operations must be carried out in this exact order. Questions often test this by inserting brackets or mixing operations. Example, what is the value of 8 plus 2 times 5 to 4 divided by 2 equals? Apply BODMAS, 2 times 5 equals 10, 4 divided by 2 equals 2 right pointing arrow 8 plus 10 to 2 equals 16. 2. Divisibility and number properties. You must know divisibility rules up to 12. For example, divisible by 2, last digit even. Divisible by 3, sum of digits divisible by 3. Divisible by 4, last 2 digits divisible by 4. Divisible by 5, ends in 0 or 5. Divisible by 6, divisible by both 2 and 3. Divisible by 11, difference between the sum of alternate digits is 0 or multiple of 11. These are often asked in one-liner MCQs and help in solving LCM, HCF and simplification questions quickly. 3. HCF and LCM. Highest common factor HCF is the largest number that divides 2 or more numbers, while lowest common multiple LCM is the smallest number divisible by 2 or more numbers. Their relationship is HCF times LCM equals product of the numbers. Example, find HCF and LCM of 12 and 18. HCF equals 6, LCM equals 36. Verification, 6 times 36 equals 216 equals 12 times 18. Use prime factorization or division methods as appropriate. These are used in time work, pipe cistern, and time distance problems. 4. Percentages. Percent means per hundred. Percentages are key to many arithmetic applications like profit loss, interest, marks, and population questions. Basic conversions. 1% equals 1/100th. 50% equals 1/2. 25% equals 1/4. 20% equals 1/5. 10% equals 1/10. Example, increase 200 by 10% right pointing arrow 200 plus 10% of 200 equals 200 plus 20 equals 220. To reverse a percentage. If A is 20% more than B, then B is 100 120ths times A equals 5/6 times A. 5. Ratio in proportion. Ratio compares two quantities, A, B. Proportion is an equality of two ratios, A, B equals C, D. Questions often ask you to find a missing term or apply this in mixtures, ages, or partnership problems. If A, B equals 2, 3 and B, C equals 4, 5, find A. If A, B equals 2, 3 and B, C equals 4, 5, find A. C right pointing arrow convert via B equals LCM of 3 and 4 equals 12 so equals 8, B equals 12, C equals 15 right pointing arrow A, C equals 8 15. 6. Averages. Average equals sum of terms divided by number of terms. It is used in ages, cricket scores, exam marks, and more. When a new term is added to or removed from a group, compare new and old averages to calculate the unknown. Example, average of 4 numbers is 30. A fifth number is added, and new average becomes 32. Then total sum becomes 32 times 5 equals 160. Old total equals 30 times 4 equals 120 right pointing arrow new number equals 40. 7. Profit, loss, and discount profit equals selling price. Cost price, loss equals cost price. Selling price, profit percent equals profit, CP times 100. Loss percent equals loss, CP times 100. Discount equals marked price, selling price. Be careful to always calculate percentages on cost price, not selling price unless stated. Example, CP equals 100, profit equals 20% right pointing arrow SP equals 120 if SP equals 120, discount equals 20%, then MP equals SP times 180 X equals 150. 8. Simple interest. Simple interest equals P times R times T, 100, where P equals principal, R equals rate, T equals time in years. Example, what is the SI on Rs? 5,000 at 6% for 2 years. 5,000 times 6 times 2, 100 equals Rs. 600. Always check units of time, convert months into years if needed. 9. Time and work. If A can do a piece of work in 10 days, A's 1 day work equals 1/10. If A and B together do 1/10 plus 1/15 equals 3 plus 2, 30 equals 5, 30 equals 1/6 right pointing arrow together finish in 6 days. Work is always additive unless someone leaves or the work changes midway. 10. Time, speed, and distance. Speed equals distance time, time equals distance speed. Units must be consistent. To convert kilometer per hour to meter per second, multiply by 5/18. To convert meter per second to kilometer per hour, multiply by 18/5. Example, if speed equals 72 kilometers per hour equals 72 times 5/18 equals 20 meters per second. If two people travel towards each other, add their speeds. If in the same direction, subtract. Previous year questions with answers. A number when divided by 5 leaves remainder 3. What is the remainder when the same number is divided by 10? Let number equals 5k plus 3 right pointing arrow try k equals 1 right pointing arrow 8 mod 10 equals 8 CAS prelims 2018. A man gets a discount of 20% on a shirt whose marked price is Rs. 500. He also gets 10% discount on the reduced price. What is the final price? First discount, 20% of 500 equals 100 right pointing arrow price equals 400. Second discount, 10% of 400 equals 40 right pointing arrow final price equals 400 to 40 equals Rs. 360 CAS prelims 2016. If 4 men can complete a work in 10 days, how many days will 5 men take to complete the same work? Work equals 4 times 10 equals 40 man days right pointing arrow 5 men equals 45 equals 8 days CAS prelims 2022. Final strategy for arithmetic in CAS exam always simplify expressions using BODMAS before solving. Practice number properties and mental math tricks for faster calculations. Memorize squares up to 30 cubes up to 15 and reciprocals for percentage tricks. Arithmetic contributes at least 5 to 8 questions in prelims, high scoring, low risk. Focus on mastering basic methods with speed and accuracy. Let me know which topic you'd like next, time and work, pipes and cisterns, or move into Indian polity or Kerala history. You said, geography. 1. General geography, solar system, ChatGPT said. Updated saved memory. Here's a comprehensive and exam-specific lecture on general geography, solar system, crafted for the CAS officer, junior time scale, stream 1 exam. This lecture covers all essential aspects from basic to advanced levels, strictly in paragraph form, densely packed with facts, concepts, and logic without wasting space. It also includes selected previous year CAS questions with answers and year references, ensuring this is the only preparation material you need for this topic. General geography, solar system. The solar system is a foundational concept in geography and astronomy, comprising the sun and all celestial bodies gravitationally bound to it. At the core lies the sun, a medium-sized yellow star, G-type main sequence star, which makes up 99.86% of the total mass of the solar system. It is about 150 million kilometers away from Earth, 1 astronomical unit, and its gravitational pull governs the orbits of planets, dwarf planets, asteroids, and comets. The solar system formed about 4.6 billion years ago from the gravitational collapse of a molecular cloud, with heavier elements gravitating toward the center to form the sun and lighter elements forming surrounding planetary bodies. There are 8 recognized planets orbiting the sun in elliptical paths, arranged in order of increasing distance: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. The inner 4, Mercury to Mars, are called terrestrial or rocky planets, characterized by solid surfaces and relatively smaller size. The outer planets Jupiter to Neptune are known as gas giants Jupiter and Saturn, and ice giants Uranus and Neptune containing thick atmospheres composed mainly of hydrogen, helium, methane, and ammonia. All planets except Mercury and Venus have natural satellites or moons. Earth The solar system is a foundational concept in geography and astronomy, comprising the sun and all celestial bodies gravitationally bound to it. At the core lies the sun, a medium-sized yellow star, G-type main sequence star, which makes up 99.86% of the total mass of the solar system. It is about 150 million kilometers away from Earth, 1 astronomical unit, and its gravitational pull governs the orbits of planets, dwarf planets, asteroids, and comets. The solar system formed about 4.6 billion years ago from the gravitational collapse of a molecular cloud, with heavier elements gravitating toward the center to form the sun and lighter elements forming surrounding planetary bodies. There are 8 recognized planets orbiting the sun in elliptical paths, arranged in order of increasing distance: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. The inner four, Mercury to Mars, are called terrestrial or rocky planets, characterized by solid surfaces and relatively smaller size. The outer planets, Jupiter to Neptune, are known as gas giants Jupiter and Saturn, and ice giants Uranus and Neptune, containing thick atmospheres composed mainly of hydrogen, helium, methane, and ammonia. All planets except Mercury and Venus have natural satellites or moons. Earth has one moon, Mars has two small ones, Phobos and Deimos, while Jupiter and Saturn have dozens. Saturn's moon Titan and Jupiter's moon Ganymede are larger than Mercury. Between Mars and Jupiter lies the asteroid belt, filled with rocky fragments that never formed into a planet due to Jupiter's strong gravitational influence. Beyond Neptune exists the Kuiper belt, a region containing icy bodies, including Pluto, which was reclassified from a planet to a dwarf planet by the International Astronomical Union in 2006. Other dwarf planets include Eris, Haumea, and Makemake. Still further lies the Oort cloud, a hypothetical, spherical shell of icy objects believed to be the source of long-period comets. Each planet rotates on its axis and revolves around the sun. A planet's rotation period determines the length of its day, while revolution. The solar system is a foundational concept in geography and astronomy, comprising the sun and all celestial bodies gravitationally bound to it. At the core lies the sun, a medium-sized yellow star, G-type main sequence star, which makes up 99.86% of the total mass of the solar system. It is about 150 million kilometers away from Earth, 1 astronomical unit, and its gravitational pull governs the orbits of planets, dwarf planets, asteroids, and comets. The solar system formed about 4.6 billion years ago from the gravitational collapse of a molecular cloud, with heavier elements gravitating toward the center to form the sun and lighter elements forming surrounding planetary bodies. There are 8 recognized planets orbiting the sun in elliptical paths, arranged in order of increasing distance: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. The inner 4, Mercury to Mars, are called terrestrial or rocky planets, characterized by solid surfaces and relatively smaller size. The outer planets, Jupiter to Neptune, are known as gas giants Jupiter and Saturn, and ice giants Uranus and Neptune, containing thick atmospheres composed mainly of hydrogen, helium, methane, and ammonia. All planets except Mercury and Venus have natural satellites or moons. Earth has one moon, Mars has two small ones, Phobos and Deimos, while Jupiter and Saturn have dozens. Saturn's moon Titan and Jupiter's moon Ganymede are larger than Mercury. Between Mars and Jupiter lies the asteroid belt, filled with rocky fragments that never formed into a planet due to Jupiter's strong gravitational influence. Beyond Neptune exists the Kuiper belt, a region containing icy bodies, including Pluto, which was reclassified from a planet to a dwarf planet by the International Astronomical Union in 2006. Other dwarf planets include Eris, Haumea, and Makemake. Still further lies the Oort cloud, a hypothetical, spherical shell of icy objects believed to be the source of long-period comets. Each planet rotates on its axis and revolves on the sun. A planet's rotation period determines the length of its day, while revolution period defines the year. For instance, Earth rotates once every 24 hours and revolves around the sun in approximately 365.25 days. This extra 0.25 day leads to the addition of a leap year every 4 years. Venus rotates in the opposite direction, retrograde, and very slowly, making a Venusian day longer than its year. Jupiter is the fastest spinning planet, completing one rotation in about 10 hours. Uranus is unique for rotating almost on its side due to an extreme axial tilt. The moon is Earth's only natural satellite and plays a vital role in geography, affecting tides due to gravitational pull. It takes approximately 27.3 days to orbit Earth, sidereal month, and 29.5 days for a full moon cycle, synodic month. Uranus is unique for rotating. For instance, each planet rotates on its axis and revolves around the sun. A planet's rotation period determines the length of its day, while revolution period defines the year. For instance, Earth rotates once every 24 hours and revolves around the sun in approximately 365.25 days. This extra 0.25 day leads to the addition of a leap year every 4 years. Venus rotates in the opposite direction, retrograde, and very slowly, making a Venusian day longer than its year. Jupiter is the fastest spinning planet, completing one rotation in about 10 hours. Uranus is unique for rotating almost on its side due to an extreme axial tilt. The moon is Earth's only natural satellite and plays a vital role in geography, affecting tides due to gravitational pull. It takes approximately 27.3 days to orbit Earth, sidereal month, and 29.5 days for a full moon cycle, synodic month. The same side of the moon always faces Earth due to synchronous rotation. Other celestial phenomena in the solar system include comets, which are icy bodies that develop glowing comas and tails when they approach the sun, meteoroids, which are small rocky or metallic objects in space, meteors, which are meteoroids that burn upon entering Earth's atmosphere, and meteorites, which are fragments that survive atmospheric entry and land on Earth. The solar system also demonstrates The solar system also demonstrates key geographical concepts like equinox and solstice, resulting from Earth's axial tilt 23.5 degrees. When the Earth's axis is neither tilted toward nor away from the sun, equinoxes occur around March 21st and September 23rd, and day and night are equal. During solstices, around June 21st and December 22nd, the sun is at its greatest distance from the celestial equator, marking the longest and shortest days of the year respectively in each hemisphere. During solstices around June 21st and December 22nd, the sun is at its greatest distance from the celestial equator, marking the longest and shortest days of the year respectively in each hemisphere. Previous year questions. Solar system. Which planet has the longest day in the solar system? Venus rotates very slowly and in retrograde, taking about 243 Earth days to complete one rotation. CAS Prelims 2016. Answer: Venus. Which planet is known as the morning star and evening star? Venus appears brightest shortly after sunset or before sunrise due to its high reflectivity and proximity to Earth. CAS Prelims 2018. Answer: Venus. Which is the largest planet in the solar system? Jupiter is the largest planet in terms of mass and volume, with over 70 moons and a massive magnetic field. CAS Prelims 2022. Answer: Jupiter. Strategy for mastering this topic. Memorize planetary order and characteristics: size, moons, composition. Understand celestial mechanics, rotation, revolution, axial tilt. Pay attention to concepts like solstices, equinoxes, and leap years. Prepare facts about special features: Great Red Spot, Jupiter, rings, Saturn, ice giants, retrograde motion. Practice map-based questions or solar system schematic drawings for visual clarity in revision. Let me know if you want to proceed next with Earth and its structure, geographical coordinates, latitude and longitude, atmosphere, or another paper topic like Indian Constitution or Kerala history. You said, motion of Earth, ChatGPT said. Here is a complete, high-quality lecture on motion of Earth, tailored specifically for the CAS Officer Junior Time Scale, Stream 1 exam. This content is written in dense paragraph form, fully loaded with critical facts, concepts, and past exam questions. This serves as your final and only coaching material, designed to take you from the base to an advanced level, ensuring nothing essential is missed. Motion of Earth, CAS exam lecture. The Earth exhibits two principal motions that have profound geographical and climatic impacts: rotation and revolution. The rotation of Earth refers to its spinning on its axis from west to east. This motion takes approximately 23 hours, 56 minutes, and 4 seconds, a sidereal day, but we round it to 24 hours, a solar day, for practical purposes. Due to this rotation, every part of the Earth faces the sun once in a 24-hour period, leading to the alternation of day and night. The Earth rotates around an imaginary line called the axis, which is tilted at an angle of 66.5 degrees to its orbital plane or 23.5 degrees from the vertical. This axial tilt plays a crucial role in the creation of seasons, as it affects how solar energy is distributed across the globe. One of the observable effects of rotation is the Coriolis force, which causes the deflection of moving air and water masses toward the right in the northern hemisphere and left in the southern hemisphere. This force is responsible for the rotation of cyclones and influences global wind patterns and ocean currents. Rotation also causes the flattening of Earth at the poles and bulging at the equator due to centrifugal force, giving Earth its oblate spheroid shape. The revolution of the Earth is its movement around the sun in an elliptical orbit, taking approximately 365.25 days to complete one revolution. This extra quarter day accumulates to form an extra day every 4 years, resulting in a leap year with 366 days. During revolution, Earth maintains its axial tilt in the same direction throughout the orbit, which causes variations in the angle and duration of sunlight received at different latitudes, leading to seasons. At any given time, one hemisphere is tilted toward the sun, receiving more direct sunlight and longer days, while the other is tilted away, receiving less sunlight and shorter days. The summer solstice occurs around June 21st, when the northern hemisphere is tilted toward the sun. The Tropic of Cancer, 23.5 degrees north, receives direct rays, making it the longest day in the northern hemisphere and shortest in the southern. Conversely, the winter solstice, around December 22nd, has the southern hemisphere tilted toward the sun, with the Tropic of Capricorn, 23.5 degrees south, receiving direct rays, causing winter in the north and summer in the south. Equinoxes occur when the sun is directly above the equator, 0 degrees latitude, on March 21st, vernal equinox, and September 23rd, autumnal equinox, and both hemispheres experience equal day and night. Due to revolution and axial tilt, the apparent movement of the sun shifts north and south of the equator throughout the year. This affects the length of day and night and the position of sunrise and sunset, which are used in calendar systems, agricultural cycles, and navigation. In polar regions, this motion causes phenomena such as the midnight sun, continuous daylight, and polar night, continuous darkness, for 6 months due to extreme axial inclination. Another result of Earth's motion is the leap year correction introduced by the Gregorian calendar to maintain synchronization with Earth's revolution. The presence of time zones is also a result of rotation. The Earth is divided into 24 time zones, each corresponding to 15 degrees of longitude, as the Earth rotates 360 degrees in 24 hours. Previous year questions. Motion of Earth. Which motion of the Earth is responsible for the occurrence of day and night? CAS Prelims 2016. Answer: rotation. What is the reason for the change of seasons on Earth? CAS Prelims 2020. Answer: revolution of the Earth along with axial tilt. When do day and night become equal on the Earth? CAS Prelims 2018. Answer: during equinoxes, around March 21st and September 23rd. Exam strategy and tips. Memorize solstice and equinox dates and their corresponding effects. Understand the axial tilt and how it affects sunlight distribution and seasons. Visualize how rotation causes day-night and revolution causes seasonal variation. Remember key numerical values: 23.5 degrees axial tilt, 365.25 days in a year, 24 hours rotation, and 66.5 degrees inclination of Earth's axis with orbital plane. Expect conceptual and factual questions, often framed around seasonal events or time-related observations. Let me know when you're ready for the next topic like latitude and longitude, structure of the Earth, or move to polity, economy, or any other paper you're targeting. You said, concept of time. ChatGPT said. Here is your complete, dense, and exam-focused lecture on concept of time for the CAS Officer Junior Time Scale, Stream 1 exam. It is structured to build your understanding from the basics to an advanced level in paragraph format without tables, with every line filled with critical information. This is designed as your one-stop coaching material, and it includes previous year questions with answers to solidify your exam readiness. Concept of time, CAS exam lecture. The concept of time in geography refers to the measurement of Earth's rotation relative to the sun, which directly influences our division of days, hours, and the establishment of time zones. Since Earth completes one full rotation, 360 degrees, in 24 hours, it turns approximately 15 degrees every hour. This rotational movement is the basis for timekeeping systems globally, where local noon, when the sun is at its highest point in the sky, serves as a reference for determining local time. Thus, every 15 degrees of longitude represents a 1-hour difference in local time. To standardize time across the globe, the Earth is divided into 24 standard time zones, each roughly spanning 15 degrees of longitude. The reference point for global time is the prime meridian, 0 degrees longitude, located in Greenwich, England, known as Greenwich Mean Time, GMT. All other time zones are expressed as positive or negative offsets from GMT, depending on whether they lie east or west of Greenwich. Countries lying in extensive longitudinal spans may use multiple time zones, like the USA or Russia, while smaller or more centralized countries often use a single standard time for administrative simplicity. Indian Standard Time East is calculated based on the 82.5 degrees east longitude, which passes near Mirzapur in Uttar Pradesh. Since India lies to the east of Greenwich, its standard time is GMT plus 5 hours 30 minutes. This means when it is noon in Greenwich, it is 5:30 p.m. in India. India uses a single time zone across its vast east-west span, although there have been debates about introducing a second time zone for the northeast to better match daylight hours. The concept of local time refers to the time determined by the position of the sun at a given place. Each place has its unique local time depending on its longitude. For every 1 degree longitudinal difference, the time changes by 4 minutes. Therefore, if a location is 10 degrees east of another, it will be 40 minutes ahead in local time. Conversely, places to the west are behind in time. For example, the local time at 90 degrees east will be ahead of 82.5 degrees east by 30 minutes, as 7.5 degrees times 4 minutes equals 30 minutes. To coordinate activities internationally, standard time was adopted to replace the chaotic use of local times. Standard time ensures synchronization within a region or country, even if actual solar times vary. In extreme latitudes, such as the polar regions, the concept of day and night itself becomes blurred, as the sun may not rise or set for months, making civil timekeeping more practical than solar observation. Another key concept is the International Dateline (IDL), located approximately along the 180 degrees longitude in the Pacific Ocean, directly opposite the prime meridian. It is not a straight line but zigzags to accommodate international boundaries. When crossing the IDL from west to east, one subtracts a day, and from east to west, one adds a day. This line maintains the calendar date globally, ensuring uniformity despite the Earth's rotation. The Earth's apparent movement of the sun also contributes to variations in sunrise and sunset times, influencing working hours, prayer times, agriculture, and festivals. While the solar day is based on the sun's position and is slightly longer than a sidereal day, 23 hours 56 minutes, civil time adheres to the 24-hour standard for practical purposes. Previous year questions. Concept of time. What is the time difference between two places located 15 degrees apart in longitude? CAS Prelims 2014. Answer: 1 hour. The Indian Standard Time is taken from which longitude? CAS Prelims 2018. Answer: 82.5 degrees east. Which line is associated with the change in date while traveling across the globe? CAS Prelims 2020. Answer: International Dateline. Exam strategy and recap. Remember the formula. 1 degree equals 4 minutes and 15 degrees equals 1 hour. Grasp the significance of 82.5 degrees east for east and 0 degrees for GMT. Understand the rationale behind time zones and the international dateline. Practice conceptual and numerical problems based on time differences between longitudes. Expect factual and application-based MCQs involving place comparisons and time calculations. Let me know if you want the next topic, latitude and longitude, structure of Earth, or to jump to other subjects like Indian Constitution, economy, or Kerala history. I'm here to build your full syllabus. You said, seasons, ChatGPT said. Here is your in-depth, lecture-style note on seasons for the CAS Officer Junior Time Scale, Stream 1 exam. This content is structured in dense paragraph form with no tables, packed with clear explanations, precise facts, and linked directly to previous year CAS questions and answers. This note is built to be your complete and only guide, sufficient from foundation to advanced level. Seasons, CAS exam lecture. The concept of seasons is one of the most fundamental phenomena in physical geography and directly results from the tilt of the Earth's axis, 23.5 degrees, and its revolution around the sun. Contrary to common belief, seasons are not caused by the varying distance between the Earth and the sun, but rather by the angle and duration of sunlight received at different parts of the Earth as it revolves. The Earth's axis remains tilted in the same direction throughout the year as it orbits the sun, and this fixed axial tilt causes different hemispheres to lean towards or away from the sun at various times of the year. The four main seasons are spring, summer, autumn, fall, and winter, each corresponding to specific positions of the Earth in its orbital path. The point when either hemisphere is tilted most directly toward the sun is called the solstice, and the point when neither hemisphere is tilted toward or away is called the equinox. The summer solstice, occurring around June 21st, marks the longest day and shortest night in the northern hemisphere as the Tropic of Cancer 23.5 degrees north receives direct sunlight. During this time, the southern hemisphere experiences winter, with shorter days and longer nights. Conversely, during the winter solstice around December 22nd, the Tropic of Capricorn 23.5 degrees south receives direct sunlight, and the southern hemisphere experiences summer, while the northern hemisphere experiences winter. Equinoxes occur twice a year, on March 21st, vernal equinox, and September 23rd, autumnal equinox, when the sun is directly overhead at the equator. On these days, all parts of the Earth experience equal day and night, approximately 12 hours each. These points mark the transitions between summer and winter seasons and are significant in both solar calendars and cultural observances around the world. Because of these shifting sun angles, the intensity and duration of sunlight vary across latitudes throughout the year. Areas near the equator experience relatively uniform weather year-round, with minimal seasonal contrast. However, regions in mid-latitudes and high latitudes experience more extreme seasonal changes. Near the poles, the effect is most dramatic. Locations above the Arctic Circle, 66.5 degrees north, and Antarctic Circle, 66.5 degrees south, may experience continuous daylight, midnight sun during summer or complete darkness, polar night during winter for weeks or even months. The seasonal cycle is vital for agriculture, ecology, climate, and human activities. It determines sowing and harvesting seasons, migratory patterns of animals, monsoon cycles, and even electricity consumption in temperate countries. Cultural calendars, festivals, and social events across the world are also structured around seasonal changes. For example, Makar Sankranti in India celebrates the sun's transition into the northern hemisphere, marking the end of winter and beginning of longer days. The perihelion and aphelion positions, where Earth is closest and farthest from the sun respectively, do not cause seasons. Earth reaches perihelion about 147 million kilometers from the sun in early January and aphelion about 152 million kilometers in early July. Yet it is winter in the northern hemisphere in January and summer in July, confirming that Earth's axial tilt, not distance from the sun, governs seasonal changes. Previous year questions. Seasons. What causes the change in seasons on Earth? CAS Prelims 2020. Answer: revolution of the Earth along with the axial tilt. During which event are day and night equal all over the Earth? CAS Prelims 2018. Answer: equinox. Which line receives direct sunlight during the summer solstice in the northern hemisphere? CAS Prelims 2016 Answer, Tropic of Cancer. Strategy for mastering this topic: focus on cause-effect clarity, tilt plus revolution equals seasons. Memorize key dates: June 21st, summer solstice, December 22nd, winter solstice, March 21st and September 23rd, equinoxes. Understand the contrast between hemispheres. Summer in the north equals winter in the south and vice versa. Visualize the Earth's position around the sun during each season for better retention. Be ready for factual as well as reasoning-based questions in the exam. Let me know when you're ready for the next topic: latitude and longitude, structure of the Earth, or if you want to shift to polity, economy, or Kerala-specific subjects. I'll keep building your syllabus block by block for success. You said. Internal structure of the Earth, ChatGPT said. Here is your comprehensive lecture style note on internal structure of the Earth, written specifically for the CAS Officer Junior Time Scale, Stream 1 exam. This note is designed to be your only and final preparation material, progressing from base to advanced level, with maximum informational density, no tables, and includes previous year CAS questions with answers. Everything here is written in full paragraph format, ideal for deep conceptual understanding and direct exam application. Internal structure of the Earth, CAS exam lecture. The Earth, though appearing solid and uniform on the surface, has a highly differentiated internal structure composed of several concentric layers, each with distinct physical and chemical properties. The internal structure is broadly divided into 3 main layers: crust, mantle, and core, based on composition, and into 5 physical layers based on mechanical behavior: lithosphere, asthenosphere, mesosphere, outer core, and inner core. The knowledge about Earth's internal structure is derived not by direct observation but through indirect methods, such as seismic wave studies, volcanic activity, density analysis, gravitational anomalies, and meteorite comparison. The crust is the outermost and thinnest layer, comprising less than 1% of Earth's volume. It varies in thickness, averaging 5 to 10 km under oceans, oceanic crust, and about 30 to 70 km under continents, continental crust. The continental crust is largely composed of granite, rich in silica C, and aluminium Al, often called SiAl, while the oceanic crust is mainly made up of basalt, rich in silica and magnesium Sima. The Mohorovicic discontinuity (MOHO) marks the boundary between the crust and mantle, identified through a sudden change in seismic wave velocity. Beneath the crust lies the mantle, which extends up to a depth of about 2,900 kilometers. It constitutes about 84% of Earth's volume and is composed mainly of silicate minerals rich in iron and magnesium, forming the so-called Sima layer. The mantle is divided into upper and lower mantle. The uppermost part of the mantle along with the crust forms the lithosphere, which is rigid and broken into tectonic plates. Beneath the lithosphere lies the asthenosphere, a semi-molten, plastic layer that behaves like a viscous fluid over geologic timescales. This is where convection currents occur, driving plate tectonics and contributing to phenomena like earthquakes and volcanic eruptions. The transition zone between the upper and lower mantle is marked by the Rappetti discontinuity. The core, also known as the barosphere, begins at around 2,900 kilometers depth and extends to the Earth's center at about 6,371 kilometers. It is composed mainly of iron Fe and nickel Ni, often referred to as NiFe. The core is divided into 2 parts: the outer core, which is liquid, and the inner core, which is solid despite the extremely high temperatures, due to the immense pressure. The Gutenberg discontinuity separates the mantle from the outer core, and the Lehmann discontinuity separates the outer core from the inner core. The outer core is responsible for generating Earth's geomagnetic field through the dynamo effect, wherein the movement of molten metals creates electrical currents and magnetic fields. Seismic waves provide the most critical evidence for the Earth's internal structure. P waves, primary waves, can travel through both solid and liquid, while S waves, secondary waves, can only travel through solid. The inability of S waves to pass through the outer core confirms its liquid nature. Seismologists also study the shadow zones, areas on Earth's surface where seismic waves are not detected after an earthquake, which reveal the boundaries and nature of the internal layers. The study of Earth's interior is crucial for understanding plate tectonics, earthquake mechanics, volcanic activity, and the distribution of natural resources such as minerals and fossil fuels. The structure also influences geothermal gradients, which in turn affect hot springs and volcanic zones. Knowledge about the core is especially significant for understanding Earth's magnetic field, which protects the planet from harmful solar radiation. Previous year questions. Internal structure of Earth. What is the boundary between the Earth's crust and mantle called? CAS Prelims 2016 Answer, Mohorovicic discontinuity (MOHO). Which layer of the Earth is responsible for generating the magnetic field? CAS Prelims 2018 Answer, outer core. Why can S waves not pass through the outer core of the Earth? CAS Prelims 2020 Answer, because the outer core is in a liquid state. Strategy and essential points. Memorize all key discontinuities: MOHO, crust, mantle, Rappetti, upper lower mantle, Gutenberg, mantle, core, Lehmann, outer inner core. Understand differences between compositional layers: crust, mantle, core, and mechanical layers: lithosphere, asthenosphere, etc. Know the role of the asthenosphere in plate tectonics and how the outer core generates the magnetic field. Focus on the seismic wave behaviors, P waves and S waves, and shadow zone phenomena for application-based MCQs. Expect both factual and conceptual questions, especially related to depths, materials, and seismic wave properties. Let me know when you're ready for the next lecture, perhaps rocks and minerals, volcanoes and earthquakes, or latitude and longitude, or if you want to dive into history, polity, or any other part of the syllabus. I'm with you until the final day. You said. Major landforms and their features. ChatGPT said. Here is your complete, high-yield lecture note on major landforms and their features for the CAS Officer Junior Time Scale, Stream 1 exam. This is crafted to be your one and only source of preparation, written in dense, paragraph format without tables, covering the topic from the most basic to the most advanced level. Every sentence is packed with exam-relevant information, and previous CAS questions with answers are included. Major landforms and their features, CAS exam lecture. Landforms refer to the natural physical features found on the surface of the Earth, shaped by a combination of endogenic forces originating within the Earth, such as earthquakes, volcanic eruptions, and tectonic movements, and exogenic forces originating on the surface, such as weathering, erosion, and deposition. These forces constantly interact to create, modify, and destroy landforms, giving rise to the planet's diverse physical geography. Landforms can be classified into 3 broad categories: mountains, plateaus, and plains, each having distinct origins, characteristics, and significance. Mountains are elevated portions of the Earth's crust, rising steeply from the surrounding terrain. They are usually formed due to tectonic forces such as folding, faulting, or volcanic activity. Mountains can be broadly classified into 3 types: fold mountains, block mountains, and volcanic mountains. Fold mountains like the Himalayas, Alps, and Andes are the most common and result from the compression and folding of sedimentary rocks due to plate collisions. These are young, lofty, and geologically active with sharp peaks. In contrast, block mountains such as the Vosges, France, and Sierra Nevada, USA, are formed when large blocks of the Earth's crust are uplifted or downthrown along fault lines. Volcanic mountains, such as Mount Fuji in Japan and Mount Kilimanjaro in Africa, are built up by repeated volcanic eruptions depositing layers of lava, ash, and other materials. Mountains affect climate, influence river systems, and serve as sources of minerals, biodiversity, and freshwater. Plateaus are elevated flatlands that have risen above the surrounding area, often due to uplift associated with tectonic forces or volcanic activity. They are generally flat or gently undulating, though they may be dissected by rivers or canyons. The Deccan Plateau in India, Colorado Plateau in the USA, and Tibetan Plateau in Asia are classic examples. Plateaus can be intermontane, surrounded by mountains, like the Tibetan Plateau, volcanic like the Antrim Plateau in Northern Ireland, or tectonic like the Deccan Plateau. These regions are often rich in mineral resources, serve as watersheds, and provide grazing lands. In arid regions, plateaus may gradually erode into mesas, buttes, and tablelands, which are characteristic features shaped by wind and water erosion. Plains are extensive, flat, or gently rolling areas with minimal elevation changes, formed mainly due to deposition by rivers, wind, or glaciers. They are often found at lower elevations and are highly fertile due to accumulated alluvium from riverine activity. Plains are classified into structural plains, erosional plains, and depositional plains. Depositional plains like the Indo-Gangetic Plain in India and the Mississippi Plain in the USA are the most agriculturally productive. Erosional plains, such as peneplains and peneplains, are formed by the long-term weathering and erosion of elevated regions. These are older and more subdued. Coastal plains, formed along the edges of continents, and glacial plains, formed by retreating glaciers, also represent important types. Plains are densely populated due to their ease of agriculture, transportation, and habitation. In addition to these major landforms, smaller features like valleys, basins, hills, escarpments, cliffs, and dunes also play significant roles in the Earth's landscape. Valleys, for instance, are low areas between hills or mountains and are usually carved by river action. Rift valleys are formed by tectonic activity, such as the East African Rift Valley. Deltas are depositional landforms formed at the mouths of rivers, such as the Sundarbans Delta, the world's largest. The constant interplay of erosion and deposition modifies these landforms. Rivers, winds, glaciers, and waves all contribute to reshaping the landscape. Rivers form V-shaped valleys, gorges, waterfalls, floodplains, and oxbow lakes. Wind action in arid regions forms features like dunes, loess plains, and yardangs. Glacial erosion creates U-shaped valleys, cirques, and fjords, while deposition results in moraines and drumlins. Coastal action by waves results in landforms such as cliffs, sea arches, stacks, and beaches. Understanding landforms is essential for several reasons. They influence climate, water availability, agriculture, biodiversity, natural hazards, and even human settlement patterns. For instance, mountain barriers affect monsoon winds, plains support dense agriculture, and plateaus hold mineral wealth. In disaster management, knowledge of landform types aids in assessing the risk of landslides, floods, and earthquakes. Landforms also impact transportation, urban planning, and tourism. Previous year questions. Major landforms. Which of the following is an example of a depositional landform formed by a river? CAS Prelims 2020. Answer: Delta. What type of landform is the Deccan Plateau? CAS Prelims 2016. Answer: Volcanic Plateau. The Himalayas are an example of which type of mountain? CAS Prelims 2018. Answer: Fold mountain. How to master this topic for CAS? Remember the three major landform types and their subdivisions. Link each landform with its formation process, examples, and significance. Learn key examples from India and the world. They are frequently asked in the exam. Focus on difference between erosional and depositional landforms. Practice application-based reasoning questions on features like rift valleys, deltas, and volcanic plateaus. Let me know when you want the next topic. Options include rocks and minerals, volcanoes and earthquakes, latitude and longitude, or anything from polity, economy, environment, or Kerala studies. I'll continue building your perfect exam set. You said, atmosphere. Structure and composition, elements and factors of climate, ChatGPT said. Here is your high-density, paragraph format lecture on atmosphere, structure and composition, elements and factors of climate, designed specifically for the CAS Officer Junior Time Scale, Stream 1 exam. This is tailored to be your only preparation material, filled with exam-relevant content from base to advanced level. It includes CAS previous year questions with answers. No space is wasted, only deep, insightful content that builds conceptual mastery. Atmosphere, structure, composition, elements and factors of climate CAS exam lecture. The atmosphere is the envelope of gases that surrounds the Earth and is held in place by gravitational attraction. It is essential for sustaining life, regulating temperature, and protecting the Earth from harmful solar radiation. The atmosphere extends up to about 10,000 kilometers, though 99% of its mass is concentrated within the first 32 kilometers above the Earth's surface. It plays a crucial role in weather and climate systems, the hydrological cycle, and energy balance. The composition of the atmosphere is primarily gaseous, consisting of about 78% nitrogen, 21% oxygen, and nearly 1% other gases, including argon, carbon dioxide, CO, neon, helium, methane, krypton, hydrogen, and ozone. Among these, carbon dioxide and water vapor are particularly important as they are greenhouse gases and play a major role in energy absorption and heat retention. Water vapor varies from 0 to 4% depending on location and controls humidity, cloud formation, and precipitation. Dust particles, pollen, sea salts, and industrial pollutants are also present in the lower atmosphere and serve as nuclei for condensation and cloud formation. The vertical structure of the atmosphere is classified into 4 major layers based on temperature gradients: troposphere, stratosphere, mesosphere, and thermosphere. The troposphere is the lowest layer, extending up to 8-18 kilometers, depending on latitude, thicker at equator. It contains almost all weather phenomena, clouds, winds, rain, and storms, because it holds nearly 7